All right. Hello, everybody. My name is Casey Hart. I'm going to keep my eye on the chat here, so feel free to send some messages. I'm really excited about this talk today. A little bit of a change for me. 2 weeks ago, I was not very excited about this talk. I accepted it. I love ontology. I love my work. I like talking to other people and evangelizing about ontology. But I also am pretty passionate about if there's a conference where the subject is innovation, like I want to make sure that I'm meeting that prompt, right? And I found myself reflecting on how do I know what an innovation is? And so perhaps apropos of being an ontologist, being someone who categorizes things, this is going to be sort of a meta presentation where I'm going to talk about, okay, what sorts of things are data models, right? What is it to build an ontological model? And where are the steps in that process where innovation might take hold? I'm really glad that this is a morning session earlier on in the process. So I hope when you come away from this presentation, you have a new way to think about, okay, what's the process of modeling something, setting up data for it, and acting on that data? And how can we categorize and look at the different places that we might have innovations there? So I hope you can take this to some of the other talks, see the innovations that they're talking about it, and fit this into the sort of framework we're going to go over today. About me, so I have my PhD in philosophy from the University of Wisconsin-Madison. I'm now an ontologist at All of AI, which is in healthcare artificial intelligence. And I do some independent ontology consulting. I got started in the ontology world. So when you get your PhD in philosophy, you think you'll be a professor. That was the aim. I love teaching. I love logic. I love epistemology, thinking about reasoning. And then I found my way into this mysterious job at Psychor for an ontologist, which I knew ontology and metaphysics, but I didn't know what ontology was in an AI sense. But I view it as like, hey, it's a postdoc and I'll think of it that way, right? And then I'll go back into the liberal arts. And I fell in love with doing ontology. I fell in love with building these models, thinking about the world in different ways. And we'll talk some more about the kinds of things that I'm building later on. But that sort of committed me to the industry and then got me into a position where, okay, how can I not just build these models, because that's fun, but how can I continue to scratch the itch of teaching by doing presentations and things like this? So if you want to talk to me about ontologies, ideas that you might have for building ontologies in your industry, questions, you're interested in consulting, those sorts of things, reach out to me. I love those conversations. My email's there. My email will be on the last slide as well. These slides will be available after the presentation. But for today's presentation, it's going to be fast. We've got, a little over 12 minutes or so to get through this. I'll try and leave some room for questions at the end. But in general, I want to talk about, okay, where could innovation fit in the process of building our data, looking at our data, and building the model, utilizing it. And then I'm going to talk about what ontologies are in particular, since a lot of my examples are going to be there. I'm not going to assume that you have any background in semantics, ontological models, those sorts of things. And then we're going to look at the 4 places that I identify that there could be innovation. So identifying the subject of the model itself, the processing of that data and the ETL, and then how we're going to use the model. Okay, so places for innovation. Maybe I'm overthinking this. I overthink a lot of things in my life, right? But if we're looking at data innovations as the theme of the conference, so a lot of these conferences just have like fluff topics, right? Which is, like an interview topic where you ask someone, tell me something you're proud of, right? We're like, basically, you can pick whatever you want and talk about that, right? And that's one way I could go. But if I don't want to do that, if I actually want to focus on something and justify it as an innovation, I want to dig in a little bit more to what innovations are, what data is, and what it can even possibly look like for some data to be innovative. So the goal here, if I want to sort of crunch that down into a more precise thesis, I'm going to push on the model aspect of a data model. And we're going to talk about how we can classify innovations surrounding that model. And I'll give an example of each of the types. It's going to be fast, but feel free to interrupt me with questions as we go. Hi, Dory. I'm part of the world. All right, cool. So what are ontologies, just as sort of a background to anchor some of the examples later? I'm going to use a lot of terms interchangeably. Strictly speaking, these aren't interchangeable and different people have different flavors of them, but I'm not going to really press on those distinctions too much. So if I talk about knowledge graphs or ontologies or semantic technologies, a knowledge layer, symbolic representation, reasoning, good old-fashioned AI. Like I kind of just put all of those into a particular cluster of things. We're building graphs, we're building nodes and links, we're looking at these edges, we're looking at relationships, we want to apply logic to them. That's going to be sort of a fundamental way that we can go about representing our data and reasoning through them. Okay. That said, almost all of this will also apply more generally to other data structures. So a CSV is not a knowledge graph or an ontology or anything like that, but you can apply almost all the lessons I'm talking about here to how are we going to formulate, common separate values documents, those sorts of things. Okay, ontologies. If we want to get like a little bit more technical about it, they're going to model your data in n tuples. Those n tuples, which are, and they're usually triples, and they're triples because it's subject, predicate, object, and then we can set it up as a graph. So you have two nodes with a line connecting them. Those are your three pieces, right? We've got a directed graph because we care about edges going in one direction rather than the other. So like Casey is the son of Diane. Those are the kinds of major components that we're going to have. And something that's supposed to be special about ontologies as opposed to other data modeling techniques is it incorporates both the data and the schema. So we're going to talk about what the relationships are, what the edges can be, what the classes are as part of the model itself, in the same way that we would put individual instance data into there. So if I want to talk about my 67 Chevy or something like that, that's an individual instance of car. That might be a class. The class car, sometimes it gets called sort of the T box, right, is my vocabulary writ large, but all of that stuff fits in the model at the same time. So sort of everything wears its meaning on its sleeve, right? And you should be thinking about using ontologies, especially if you want to have AI that's understanding your data, or if you have some core base of knowledge that you want to reuse over and over again, you want to improve. Ontologies and knowledge graphs are especially useful for sort of that repeat knowledge where multiple different applications will be hitting the same bucket and benefiting from improvements there. Also really useful if you want to do symbolic reasoning, deliver explanations, or you have a trail that needs to be audited, sorts of things. Okay, so here are some paintings. Why are there paintings? Where the heck did that come from in the presentation? So this was in some of my long walks to figure out, okay, what is a data innovation? What does this look like? And I was like, okay, ontologies are models. I was like, what would it be like for like a sculpture or a painting to be innovative, right? Like, what are the most famous paintings? How does that stuff show up? And so we've got like the Pietà, one of the most famous sculptures of all time, incredibly realistic, evocative of a very particular event. I'm not a specialist in art, so I'm probably giving like very elementary analysis, right? We have the wave, we have the scream, right? These things use color in different ways. They use a woodblock technique for the tsunami, right? They also evoke particular things. Like, why do these things stand out? What makes them innovative paintings, right? What makes Picasso innovative? Like, when you compare that to the sculpture on the far left here, right? The Pietà is like incredibly realistic, but Picasso not super realistic. Like, why is that? So it's not just that it's realistic all the time, right? So innovative art and sculpture, to my sort of basic understanding here, what makes that stuff innovative is if they're using new techniques, or they're causing you to see the world differently, or they are evoking a particular set of feelings or insights in you, right? So when I look at this painting of Picasso, I feel a certain way. When I look at the Mona Lisa, I feel a certain way. I wonder about why she's smiling, those kinds of things. How can we make those innovations transfer over to our data, right? And what the heck is data? So broadly, I think data should have a very general definition. Our model, our data, is just a picture of the world, if I want to push on this metaphor, right? It's a sculpture of the world. It's telling us some information and storing and codifying that information. So something in the upper right here, like the rings of a tree, that's data. That tells us how old this tree is. Maybe the thickness of the bands tell us how much growth there was in those years, which tell us something about precipitation and temperature, those sorts of things. You can have a triple in this green box from an ontological model that says this tree has an age of 20 decimal, right? Or you can have a relational model where we just have some table that says in this row, we're talking about objects like trio 1, which is 20 years old and is Douglas fir. Great. All of those things we can think of as just they're telling us something about the real world, right? They're snippets, representations of what's going on. So if we step back then and say, all right, in this whole data process, what's occurring? We've got the world on the left. There's something we're modeling, whether that be a tree, whether that be your customers, whether that be your products and services, whether that be the amount of cancer cells in a particular lymph node I have, any of those things, that's part of the world. And we want to take that world and we want to put it in data format, right? We're simplifying it in some way and putting it in sort of a capturable, digestible format. And then that data is going to be utilized by humans. Now, the world's going to be held fixed. I'm not looking at what are the innovations in the world for this sort of project. I'm looking at sort of how are all of these processes downstream from the world? Where can we be innovative about the way that we create, maintain, and use our data? So 4 places that we might look here broadly. I snuck in a 5th this morning, but I think it's a sort of a subset of techniques for modeling. So the first choice we have is what data are we capturing? So if we look back at the slide about the trees or whatever, right? This is only capturing the age. This is only capturing the age and the species. There's a whole bunch more to say about the tree, right? We could talk about the tree's height. We could talk about its weight. We could talk about the density of the material. We could talk about the colors of each of the rings. So many, like infinitely many true facts about the tree, right? So when we're making our model, we have to make selections about what stuff is going to come across. Then we have the techniques for the modeling. So what is that data going to look like when it's stored? Is it in a CSV? Is it in an ontological model? Are we going to put it in one data model and then do some ETL to move it over to another data model? How is that going to fit? And then the next step is, okay, we've got the data fixed. How are people going to access that data? Are they hitting it with APIs? Are they writing Sparkle queries? Are they writing SQL queries? Are we building some application that surfaces it to them? And then, even if we hold all of that stuff fixed, you still have some person, some company, some organization at the other end that's using that data. How are they going to be using that data, right? Are they going to be very data driven in their insights? Are they going to be generating more data and do some sort of feedback loop, right? Whatever the interface is, it's still, we can be innovative in how we manipulate and use that data once it comes out the other side. Okay, cool. Any questions on that stuff so far? I see a couple of hellos in the chat, but no specific questions here. Feel free to throw some up as we go. And then we've got 5 minutes or so to sort of fly through some of these examples. So on the subject, on the world, deciding what's captured, there are a couple places here that I think we can be innovative. We can be more realistic, right? Again, using the Pietà as an example, or we could be more minimalistic. Maybe think more like the Picasso style painting, right? Where we say, let's only focus on a couple of the features and make them really big in our data. And that's going to draw out certain things. Another place you might go is pick some very unique pieces of data to pull out, right? So everybody, if you want to talk about a tree, maybe is focused on its age and its height and those sorts of things. But maybe we could have a data set on just the roughness of the bark. Like, because that's data that a lot of people aren't capturing, you might be innovative in that that's particularly useful and fills some gaps that other data sets are lacking. So some examples. For me personally, I prefer the realistic approach. I have very dense ontologies. I want my models to be really complex, because I think when you make a simplified model, you're losing information and you're never going to get that back. Conversely, if you have a complex model that has some practical problems with how, are queries slower, those sorts of things, I think you can solve those practical problems, but you could never shove the information back in if you've oversimplified it and lost it. So that's a main area that I try and innovate on this front. Another innovation, I like to think about sports things. So on the collecting new and unique data front, very prevalent in football, in basketball sort of especially on the cutting edge on some statistical things, right? Calculating how far players are running in a given game, right? That's not something that we were collecting in the 80s. That's something that we're collecting now, and you can use that to make some insights about which players are maybe going to be more tired at the end of the series, or which players are going to be harder to defend for opponents, or which players like Maxi are doing a better job chasing someone down in a particular series. Yeah. Good point, Olga. So they are harder to interpret. And I think there are practical ways that you can make them easier to interpret. You can nest things in certain ways so that more specific concepts fall under more general ones, and that makes them easier to sort of parse. But yeah, there are trade-offs for all of these things. And if that's a decision that you're trying to make, how complex do I want this to go? Would love to talk to you about that, because I think that's one of the most important decisions we have as data modelers. Second level. So now let's say we've decided what part of the real world we want to put into a model. Great. how do we choose what the model is, and how can we be innovative on that front, right? Couple things that go on here. One is just we could be novel in picking new data structures that people haven't used before, or we could use different types of software to model them, right? So whether you're in the ontology front, whether you're going to use Protege or TopBraid or something in Stardog, whatever, right? Or roll your own new model, that's where novelty might come in. So one place just very generally here, well, I'm an ontologist and there are lots of ontologies. We had a Stardog presentation earlier. Knowledge graphs are ubiquitous. That's great. But if you haven't considered using ontology in an industry where they're not prevalent, that's one way that you could be on the cutting edge and you could do something innovative, right? You can also talk here about building new pipelines that import your data into an ontology from various formats. Another place where I think we're sort of underselling novelty or innovation here is who you're hiring to do your data modeling. So if you are only looking at a certain set of people who have worked in, database administration or have a data science degree, that's great. Those are all very good people. But maybe look at some other industries, right? Say, what if we take someone from one field and put them in this field? Or take someone like myself, who's a philosophy PhD, wouldn't have thought of myself in a data science role. I think I bring a unique perspective because I came from a philosophy background, right? Take some people who don't have data experience, but who have subject matter expertise and try and put them into that role. The more diversity you have in the building of the models, the more interesting and innovative models you might end up with. Okay. You can also add, and this is something I don't have a lot of time to get into, so I'll just leave this slide up here, and it's a thing that you can look back later, but you can make new vocabularies in existing vocabularies. So OWL has stuff about how we can make an OWL restriction to talk about all the things that stand in a certain property, but something we've done at Olive, myself and Nick Monagani, is how can we add some syntactic sugar to that to simplify the language and allow it to be more expressive while sort of highlighting the use of fewer properties. Cool. All right. The next place, process and ETL. So we've got our data, we've put it into a model. Now, how are we going to process and have people interact with that data? So here it's going to be user interfaces, what sort of query languages that you're using. Are there different modalities? Are they wearing 3D glasses while they look at your user interfaces? What sort of pipelines can we build? To be honest, this is where I have the least innovation on the process part. I think user interfaces, again, to use a sports example, we can put way more information on the screen than we ever did before. Those are good places for innovation. You can think about how you can incorporate more data in sort of the UIs and the other tools that you use. The other place is on ETL. So what sort of processes are you taking to extract, transform, and load your data? Lastly, and I know we're coming down to about the last couple of minutes here, how are we using the model, right? So on the art front, some art can be interactive. Maybe you make a bench that you also sit on, right? Organizations have a lot of control in how seriously they're going to take their data and how iterative they're going to be with their data. So I think the biggest examples here of innovation, all of myself sort of history, is putting metadata on things. So not just using the data, but tracking how people are using the data and allowing that to drive future insights. And then allowing those users to put data back into the system, create some feedback loops. So if you interact with the data and you don't like it, tell me why you don't like it. We'll add that to the model. That will enrich it and give us more value going forward. All right. And now we're 20 minutes after the hour. So I've made it to the last slide somehow. If there are any questions, we'd be happy to take them. I know I'll probably get cut off relatively soon. Also, if there are any questions, please reach out to me. I love having these conversations. I had a few after the last DSC conference, and they were really enriching. So please don't hesitate. Thank you much. Questions? I see Timothy with the comment there about diversity of tacit knowledge. Yeah, that's really important. When you're building data, it's incredible how much when you talk to people who work at your company, interact with the data, they're like, oh yeah, well that's not written in the data, but I know it, right? How can you extract those pieces of knowledge? It's really important. Thanks, Ashley.